So there we go. Recording is started. We are live for SUSE QE Tools Workshop this day on the 12th of May 2023. Today, we would like to continue our series on walkthrough of the individual OS backends. The last time we had been talking about the IPMI backend weeks ago. So today we will talk about SVirt backend. The SVirt backend, fancy link here, is zoom in a bit. Is this readable for you guys?
Yes, it is.
Yep.
Thank you. So the SVirt backend, basically it's described by these two sentences. This is a fake backend to some extent. I would call it a stub backend. We don't start VMs directly, but provide SSH access to a libvirt running host. KVM for system set in mind. So this is where it actually started, but we can already see immediately after that where it mentions Hyper-V. Actually, let's start from the top. From the top. So as a base class, we have the virt backend. The virt backend is just a generalized base class, so not usable as a backend by itself. And then later on, we say that we have different variants of the backend. So it already mentioned KVM for system set. So on S290 mainframes, you can have an LPA with an installation of Linux like SUSE or OpenSUSE. And you have libvirt running on that, which allows you to run actually QEMU. And we can connect to that machine over SSH, and all of that is abstracted by this backend so that more or less it behaves like a QEMU backend. However, so far, this backend is relying, I would say, heavily on more specific handling in the test code. So we can take a look into that based on examples. We have two functions which already show that we support Hyper-V and VMware. So it's like, I would say, three different variants, the pure libvirt, then Hyper-V and VMware, which more or less behave the same, that you have a remote hypervisor host to connect to that remote hypervisor host, and the actual machines run on there. So that obviously means that for starting, stopping, and controlling the VMs, we need to connect to that instance, but also to get any kind of output back, we need to tell the hypervisor host or the machines from there how to send the data back, talking about the BNC display as well as the terminal output or serial terminal output. So let me remind you about the basic interface that we need to fulfill. So we have the null backend, which shows that those are the bare minimum so-called abstract methods that we would need to implement. Do start VM, do stop VM. That's it. That's a new GitHub. Okay, cool. So it's still telling us that reference. Do start VM, do stop VM, extract assets, run command, can handle is shut down, and stop serial grab. So now going back to SVirt, we have the implementation of those functions where we have to start VM. And the most important thing what this one is doing is creating a console. So we have that console. Remember that concept of consoles where everything is a console. You have a console to the hypervisor itself. In QEMU, you have this QEMU console, which is really not used or visible to test layer. It's more like lower layer. Then you have something like the main machine output in QEMU. That's where you would see VNC, but also the TTYs. the IPMI backend, you have the serial over LAN as a console that you get from this bare metal IPMI connection. And here we have an svirt console which says SSH virt SH, so it's connecting to the hypervisor host over SSH. And this is why we also obviously need variables, like we need a host, we need a username and a password. And then we tell the console that we created about ourselves, so a back reference. And now in do stop VM, we actually do stop the virtual machine, and we can already see applications. You can see that there's kind of interesting additional feature here, so that on request you can keep the virtual machines running. Now I don't know what that is used for. At least I could imagine that of course it could be useful for investigation purposes. So that instead of making the stop clean up itself and then the backend shutting down the machines and destroying the virtual machines, you keep them running on that remote hypervisor host and statement. And for that, we need to identify how is that virtual machine reference on the remote host, depending on the specific hypervisor functionality. So you can see that for Hyper-V, what we do is we use a PowerShell command. So basically you say PowerShell command stop VM, and then you give it a VM name, and you run that as an H command, meaning like you send that command to the remote machine over the existing SSH session, and then execute PowerShell within that remote context. And then additionally, then after stopping the VM, it's removed, so the definition is destroyed. And I don't know how in Hyper-V that is handled, if there are any assets connected like a virtualized hard disk, if that is also destroyed along with the machine. Else we do that with the virsh libvirt d command line client. So we construct the complete command, where to connect to, if that is specified to be a remote instance. And then we call virsh destroy on the undefined, so the equivalent to what we had in before, stopping and removing. And then if we need to handle the remote lock, then we call SCP get, which is a function also defined in here, and then call delete lock in the same. So SCP get, what does that one do? Again, we are using an SSH connection. We create file and we basically copy the remote content into the local file and then disconnect that SSH session that we just created in here. The can handle function is coming from the backend class definition. What this one is doing is each backend can then tell OS audience if it's able to support functionality, like does it support snapshots, and that's then checked with the VM family. If it's one of those, then we say yes, we support snapshots. Otherwise, we return on a negative result, meaning that's not supported. The is shutdown function implemented here, so it's let's say a bit equivalent to the do stop VM, only that this is only checking. So in case of Hyper-V, we run the remote SSH command. We call a PowerShell command where we try to get information about the current virtual machine identified for VM name. and then we check if the state is off, and if yes, then we return with reporting exit code resembling the Boolean output that we store in RSP, and then we and the equivalent for libvirt is that all that with virsh dom info, then we grab for shut off, and then we negate the result. So then we can also directly evaluate the value, which is we do support snapshots. So this is why we have the following two methods: save snapshot and load snapshot, meaning the default execution, same as in chemo-based tests, is that if there is a normal test module executed and failing, and the virtual machine is rolled back to the last good snapshot, so that we have consistent state from where we come. Phoenix?
Is this supporting live snapshots or only offline snapshots?
I assume it's really actually we need to check what it is doing. So let's go through the implementation, because I don't know, and then we can deduce it from there.
Yeah, thank you.
So for Hyper, we want to save a snapshot. It's removing snapshot, maybe because it cannot override it or something. And then there's a function called checkpoint VM. It doesn't really tell me much. I guess we will see in the loading. In libvirt we actually do the same, that we also delete a snapshot and we say snapshot create as, and then we assume that a snapshot has been saved that we will later reference by name. So now the interesting part happens in load snapshot. So when this is actually called, in case of Hyper-V, there seems to be some kind of workaround. So first, what we do is we call restore VM snapshot. I assume that we can actually do that while the VM is running. So that's how I read the code, but I'm not exactly sure. That's what I assume. And then we create a backup of some file. Okay. Then we have a loop, because there's some upstream free RDP issue. So we need to apparently try that multiple times to see if the process is running. And in case of libvirt, we do snapshot revert. So that really sounds like a VM is running and we tell the VM to go back to a certain state, but it's actually a persisting VM. Do you read it the same?
I think so. Based on virsh, I can't say, but I would assume so, yeah.
Yeah, but for sure that's like within one test run. So in any way, it is kind of transparent to the user, right? So within a test flow, that should happen. So you as a, let's say, as a test writer, you wouldn't need to actually care about that, and you can assume that all the system parameters are preserved, including something like the network. So same MAC address, same IP.
Let's try a different angle. Does the svirt backend support the snapshot within a test run and rolling back to those?
But that's how I read it, yes.
Then it should support live snapshots, because that is a necessary requirement. If that is supported, then I assume it is. Yeah.
Okay. Good. Get SSH credentials. I haven't seen, where did we? In SCP get. So we get a hash of credentials, and those credentials, they are virsh host name, username, and password. So how do you connect to the hypervisor host? Only the username is defaulting to what one commonly has, and hostname and password actually required. So you do need the hostname and the password, and then you can connect to a libvirt instance. Obviously, that libvirt instance can also be local. So if you want to test that or use that locally, you can, right? I mean, just install libvirt.d, can choose to install Virt Manager as a GUI, but you can then use this to connect locally and run, instead of Qemu, you would run libvirt-based machines, which is, I would say, a negligible overhead or not relevant overhead if you like to do. Does it provide a benefit? Yeah, it depends. It would provide a benefit if the actual test target does include that you want to run something on libvirt. So, you know, if the OpenQA worker or the machine that you run OS Audience on is part of your test object, then you can use that backend. And for Hyper-V, we have additionally the requirements to use credentials for Hyper-V intermediary host. Because I think how that is actually used is that, or how it's intended to be used, or how it's actually used right now, is that you have a remote instance and oh wait, it says credentials for Hyper-V intermediary host, and then it's saying Virsh guest. Honestly, I don't know what that means. Can anybody explain that? I don't know if Virsh, I mean, we need the Virsh host name and password anyway. Now that is required additionally if you're running on Hyper-V. We can take a look into examples later on and see how that's used. Okay, start serial grep. We have again that we are getting credentials, and then we use. Here you can actually see the 3 different variants that are used. In case of VMware, now this is one of the first time that this is mentioned explicitly in a logic branch. We use SOCAD. And SOCAD is connecting to the VMware host on a VMware serial port, and then you have pipe over which you can get the live data by that process. For Hyper-V, you do the equivalent with SOCAD on Hyper-V server and Hyper-V serial port. So that means on the Windows host, there needs to be some application that is providing the serial terminal output on a network port on TCP, which we can connect to with this. In case of libvirt, Virsh console is used directly, so that's, I would say, is a more convenient way because you can directly use that command and then it giving you the live output. And then, yeah, some error handling. There's open serial console via SSH. So that is the actual connection attempt to get a serial console, not the serial grab. So I think that's the equivalent to the, let's say, the read-only serial console, and then you have your serial terminal, maybe. No, wait, this one says Virsh console, and this one is serial console. So I might be confusing those two. This is maybe just a serial terminal log file. But in any way, what is also done here is that there's a connection done with SOCAT for VMware and Hyper-V, and for libvirt is wish console. And then some checking if the log file exists and waiting until the log file does exist, and then looking for some marker in that log file to continue from. Delete log, it's actually cleaning up the log on the remote instance. Why that is done, I can't tell you. Then there's implementation of die where we say we need to delete logs, then we call delete log. So this is actually calling that remote function. And here we construct a unique path for the serial terminal log file. So that one is then used on remote host to identify the file that needs removed because of this unique job token. That's why I assume they would also pile up and wouldn't be reused and overwritten this why it's deleted. And then there is this funny function which only returns 1 or 0 with a lengthy comment about a sporadic error, but a proper ticket reference and a nice explanation why that is needed. So certainly already some quirks which are, you know, backend variant specific are handled in here. Okay, looking at that code, what I see is that basically we have a nice object-oriented structure where we say this svirt backend, which you can select by backend equals svirt in your test or in the OpenQA worker accordingly. That one derives properly from a base class and it implements an interface. I would say the software design is not clear in that those variants like Hyper-V and VMware are mixed in with procedural code. What one could do to improve is to extract all if-elses into variant-specific sub-backends. So, you know, that's something that could be tried to say, why not create a backend which is called Hyper-V on that level, and then Hyper-V would inherit from the svirt backend, and it would override the specific implementation part, maybe not the complete do stop VM function, but only the specific remote commands like do stop VM remote command could be this implementation. And the very same you would do for the other variants, which you would keep in that or keep that in the base class. That's what I would say would make it look a bit cleaner. Same then for the shutdown function, same for save snapshot, load snapshot, get SSH credentials, start serial grab, and open serial console via SSH, because you have all those if-elses in. But that's a bit up to decide in some cases, like is it worth to have a separate base class? Do you think it's cleaner, or is it also beneficial from the point of using the backend? Now, any notes or questions regarding the code that we looked at so far? Any corrections? Because, you know, again, as for the other backends, I'm far from an expert. I'm just trying to read the code myself, which I'm not that familiar with, and then trying to make sense of it. Okay, then maybe we can try to look at some examples. So Taking a look on OpenQA OpenSUSE.org, if I'm taking a look for svirt, then why does that one show up? I don't know, it doesn't mention svirt. Hyper-V, VMware does nothing, so no machine definitions included. Are there any workers? I already took a look. svirt, nope. 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 So this is not used on OpenQA OpenSUSE.org. Okay? So it's not used there. There is no machine currently in the network that would provide such functionality, even though, you know, it wouldn't be that problematic. Any OpenQA worker that's running QEMU, we could just install libvirt on top of it, you know, starting QEMU machines manually and libvirt managed machines in parallel doesn't really conflict unless you are exhausting resources. So that could be done. And also, let's say a Windows server with Hyper-V is also not that problematic. How much that's possible in a VM with nested virtualization, I don't know, but I think at least the basics should very much be possible to. We do find examples if we take a look on OpenQA SUSE QE. So if we take a look here on the OpenQA SUSE QE defined machines, then you will see one example where it was used from the beginning is S390X KVM, and this is also an example which I will quickly show then. So this is where we use the svirt backend, and this is where it was originally developed from. If we look down a bit further in the list, then yeah, this is where we find svirt Hyper-V. So that's like a second example. And then there's also svirt VMware. So all those variants are used on OpenQA SUSE QE. This is also why that backend was created. And this is where, you know, you can also see in contributions that some QA engineers from SUSE have created that backend and extended that backend. So let's take a look. If I can find some samples. 15. Let's take a look for 15 SP5 test with machine equals S390. Was it S390X KVM? Yes, S390X KVM. Okay, that did not work. Machine S390X KVM. Ah, there are none. Interesting. Okay. Then where do you guys have those tests? Not in 55. What am I missing? Okay, then let me just look for S390X as an architecture. So what is this default scenario using? It's using S390X KVM SLE 12. Right, so we have those variants. KVM SLE 12. So what does that SLE 12 suffix mean? That means that this machine is intended to be fulfilled by a worker that is actually running SLE12 itself, because here the hypervisor is part of the test object, right? You want to test, or we want to test SLE12 as a hypervisor host running libvirt with chemo machines on S390. So there's this variant. And then there's also S390X KVM SLE15 as another variant to say that's a different operating system, a different hypervisor host of filling that class, and then showing tests there. So let's take a look into the used variables. So what we see is that it says backend svirt. So yep, that's what we have seen. We know that there are some variables needed to make that useful. Yep, so we have some variables with virsh in the name. So we have virsh host name. That's actually what we need for the backend. More variables are used, for example, virsh instant, virsh mac, virsh guest, virsh command line, because this is used in the test code. If you remember, we haven't actually seen any command which starts the virtual machine itself. And also what we did so far is we identified the actual virtual machine by name from the hypervisor host. But if we want to connect to it over network, or if the machine wants to connect elsewhere, then it also needs to know how can it be addressed in a network, which is actually visible here. So we have a SUSE IP here. Okay. If we take a look into the details, then we see the bootloader set KVM module. And what that one is doing is connecting over SSH. Where is it connecting to? It's connecting to the hypervisor host over SSH using, now this is becoming interesting, using an application which is called Xterm console. So it looks very similar to a TTY on a chemo machine. Like if you have an OpenGate test using the chemo backend and you create a virtual machine there and you press Control Alt F1, same as on your physical computer, you would see a TTY with a login prompt. And it's using the same font that we use here. There are two differences if you look at that to identify this is not a local TTY. First, it's showing you that warning, which is SSH specific, and a password, which is actually the password for the remote access for the already established SSH connection. And second, there's this mouse cursor. So it's actually an X server. This is an X server, and on that X server, we're running a full screen terminal, and from within that full screen terminal, we execute those commands. And you can see that this is now that the password was accepted. So we are in the process of login. And then there's the prompt. It already started typing. And those are remote commands using virsh. So with virsh dump XML, what you can see is that existing machine definitions are shown, and then they are passed for certain parameters. And then we echo the PTY, so the variable there. Yeah, we see some, let's say some debugging information, so we know what specific SUT this runs on, and then if we continue here, this is one, let's say, not so nice part about the implementation of the bootloader set KVM module, that we are always looking at the terminal and you have multiple steps that you don't see anything progressing. Why is that? Well, because in the meantime, there's something going on over another console which is not shown here. So it's a bit like you type into one console showing up on one screen, and there's a neighboring screen where the actual action happens, but you're looking on the wrong screen and you wonder where are all your characters ending up. But in the end, they have an effect. Then what is actually continued in that terminal, remember we are connected to the hypervisor as host, is that we need to transfer the assets. Compare that to the default case of a Chemo backend. In Chemo, you would run Chemo on the OpenQA worker host, and the OpenQA worker host would have ensured already that all assets are transferred from the web UI, like build 98.1, and from build 98.1 you have like the ISO file or a QCOW file, which you have transferred from the web UI to the worker host, either as a downloadable asset or NFS share, or what's commonly done over the so-called worker cache. So it's local on the OpenQA worker. We also have that OpenQA worker here. The assets are actually transferred to the worker host, and that's a redundant operation because nobody is ever going to use those assets, because instead what we do is we download again directly here with wget from the web UI host to the initRD target, and then we do the same for the we do this same for the Linux kernel. And after we do that, then we tell the seed, so there are multiple steps going on where we don't see the output, and then we see that the virtual machine is connecting. I will show you the content from the log. I just want to show you that from here on, this looks like the very same screen that we are used to. We have a graphical installation, and we continue with the Just installer in a graphical way. Of course, there are also text terminals which are less elaborate. They basically follow the same scheme. Just zoom to the after installation. So what we see here is that after installation is finished, then we have multiple consecutive black screens. Is that supposed to be like that? Well, I would say that can definitely be improved if somebody would look into that. I would appreciate that, because this is confusing to users. It doesn't really help to know what's going on and why that is. And there's this kind of helper test module, which is not needed in case of Chemo, where we reconnect to the hypervisor host. Why do we even disconnect the SSH connection to the hypervisor host just because we reached the VM? I don't know. I think that's actually an error. And this is why a reconnection attempt needs to be made. And then, yep, we do more or less same as we did before. We identify the console, and then we connect to that console. A difference is that we now have a device which corresponds to the console output, so we can look into that directly. Zoom to the end. This is like just the standard test modules. Now they are all behaving the very same regardless of the backend. Only that in the end, when we do console finish, yeah, we see that in the end we log out. So that's the final call, and those steps actually different from the Chemo backend. If we take a look into the log file, let's take a look for all executions of virsh. So virsh dump XML. That's the one command that we do on the remote instance to get information about the defined machine. And then we have cell. I don't. Yeah, there's some debugging information. DOM stats. There, DOM stats. and then virsh destroy. So the remote VM, if it does exist, it's destroyed. It's actually looking if that's not found. And we do that before we create the machine again. So it's also undefined. And then we define it based on XML file, which is generated. And after the definition, then we do the actual virsh start command. So why is that outputted multiple times? Well, that's the nature of how the functions are called. So we call run SSH command, which internally calls run SSH. And then from the remote end, there's use existing SSH connection to the hypervisors. And this is the confirmation from the remote execution, including the output that we get from there. So it said domain opencase sut9 started. That's the output from libvirt, right? And we see that we have an exit code, which is 0. So meaning that the remote execution has passed. And then we pass that back to the upper layers, and then the backend knows that this command was executed successfully. After start, then we call oh, sorry, this was jumping a bit backwards. So here we have start, then we have dump XML again, and then the execution goes on until we want to connect to the console. And here we are already at the end. So we finished the last test module, finish console. And then the only thing that we need to do is check, is it already shut off? And if it's not, which is the case here, then we call virsh destroy. And then it says here that the domain has been destroyed. After destroying, undefined is called. So after that, the machine has been stopped and removed, and then we are clear to exit up. There are some not so nice error messages here, which you can see here. That's related to an X server. It says resource temporarily unavailable. Now I think this is because, you know, there are remote commands, and then suddenly the remote end vanishes, and this is not properly cleaned up. So this is another point for improvement, where, you know, one could first clean up the remote instances properly before trying to end the other side. But in the end, what we can see here is that it ends with 0. We are uploading the results, and we are done. Okay. Questions, notes, correction for that part? Doesn't look like it. Anything else that you would like to add for this topic of the svirt backend? Yep, Jim.
Do you have an example with Hyper-V?
Yeah. Let's take a look. So the machine, something with Hyper-V. So there's svirt Hyper-V, svirt Hyper-V UEFI, and then also different versions of the remote hypervisor host. So take a look. Hyper-V. Yeah, there's nothing for Hyper-V. Maybe the same problem as in before. How about svirt Hyper-V? Nope. Let's try Hyper-V.
There is a link in the chat from Jose.
Yep. Here. Right, so this is JUICE for MS Hyper-V. So, you know, we don't do a complete installation, which makes sense, but we predefined appliance. So what we see here is that here the backend is defined, and then also here we have a helper test module. So I would say also not that nice, because the test writers actually need to know a specific implementations. I actually thought already that we do have a generic bootloader module, which then should, abstract away the selection of the specific backend. I don't know why that is used here. So there's bootload Hyper-V, and you can see that it's handling, let's say, some Windows specific things. It's looking into parsing the output from the remote PowerShell commands. It's also mounting remote instances, etc. Yeah, Pavel?
Yeah, well, I don't know. I mean, well, I don't work with this backend for some time already, but when I did, I remember that it was actually quite funny that first of all, yes, on Windows you have SSH server and you have PowerShell, but PowerShell is very different. So it's, for example, does not return 0 when the command is successful. So
Yeah.
we have to parse the output and do. It's still not that simple as one could, assume of having a actually shell.
No,
And also,
absolutely. No, it's a different shell. Yeah.
yeah, and also as we need the serial console for testing Hyper-V, and it's not there by default. On every Windows Hyper-V server, we are also running small program, which is creating some TCP serial, which is opening like TCP ports because of the serial console. So
Yeah.
it's
The remote
also,
backend of the SO card process where we connect.
yes, exactly. And this software is quite ancient, and yeah, it's still hacky.
Yeah,
also think.
I know. There had been related work in the related ticket. I suggested to just use SO card on the server side again. I don't know why that was not further evaluated, but I think the suggestion.
Yeah, probably. That's interesting.
Yeah.
I agree.
Okay. So what we see here still is equivalent to what we have seen on the on S390 KVM. Is just that obviously already by the domain you can see Win2K19. So this is a Hyper-V host. So it's actually a Windows server running an SSH server, which is completely fine, because nowadays you can also just select to install an SSH server within Windows. So that's pretty nice. And then yeah, logged in, it actually is and yeah, okay, and that is now for me the a bit confusing part. So there's another host which is called jump host. I don't know why that is needed. Okay, and then on the jump host, doing something with starting a separate VNC server. And then I guess it's running free RDP within that, connecting to Windows, and then we connect from the OpenGL worker to the jump host over VNC. So it's likely VNC from worker to jump host, RDP from jump host to Windows. So yeah, all the let's say the user experience of that is also horrible, because multiple repeated steps only showing something about errors and repeating itself, and a lot of typing. So far from perfect for sure. But in the end, still what you get is the output, which looks like the Linux target run. And then from here, so that's the important part, you can see that you know you cannot even recognize anymore if that is coming in remotely from an Hyper-V host VM or a libvirt-based VM or a QEMU-based VM. And that was the idea, because it's abstracting that all away, meaning that all those test modules, and I hope this is true and nobody is doing quirky workarounds within the test modules, but all those test modules should really run ignorant to whatever backend has been. I would say the need to have this intermediate test modules is not perfect, but it serves the purpose to bring the machine into a state where from here on, you would just say like, okay, from here on, I just don't need to care more about a specific backend. It's just doing its job. Right? Yeah. So what does that mean for the svirt backend in the future? I would say, well, it's doing a job. There is a limited workload on that. It's not used on OpenQA OpenSUSE.org. So it's limited in its use. It's important for some use. It could be improved code-wise. It could be improved feature-wise. And in particular, it could be improved regarding the, let's say, the user experience to make it, to streamline it more, especially the, this repeated screenshots showing not the thing that you're actually interested in, but something different. And also then, potentially confusing errors in the output whenever there is a problem, then people will say like, oh, maybe that is the error, but then it's output that would be for long. We do not have plans within the SUSE QE Tools team to work on those topics right now. However, same as for the other backends, we already invested some effort to have proper unit test coverage for all those backends. So anybody of you that would be interested in contributing and improving this or other backends, you're very welcome to do so. You have the safety net of unit tests, and we will also support you in according pull requests or questions where to import. So that's I'm in the end of that topic. Anything else that you would like to add or ask about?
It looks like there is no documentation about that.
Right, good point about that. I think there was. Take a look. So in backend, no, we don't have more here, but we have the folder doc, and there's the backends document, and it does mention the svirt backend. In also mentions in particular how can you use that. I mentioned you can use that locally just fine. So for example, if you want to configure an OpenQA worker to use the svirt backend, you can just use that, and you can see that's like connecting to localhost. And then you need the according SSH configuration and the packages and libvirt starting. And also it explains how you could clone a QEMU job into an svirt job, trying with that. There's also explanation about the VMware ESXi hypervisor using with a local Virch client. So also that I would say is sufficiently covered in let's say developer-oriented document. Okay. Good. So thank you all for your interest. The next 2 appointments we will skip due to a public holiday bridge day in many regions. And then after that, we have the OpenSUSE conference. So we will also, give that roadmap, that workshop appointment. The one after that is the beginning of the next month. So we will do the next SUSE QE Tools roadmap presentation there on the 2nd of June, and hope to see you then. And after that, we will have the second part about OpenQA trigger from OBS. After recently we had the bigger overview and introduction, we want to have a session where we really want to share real life examples. So all of you are invited to also share examples of specific configuration, special configuration problems. We can also try to make it fail tests to understand what it is doing for extensions of this configuration in repository and fix problems you will have. So until then, thank you all and see ya. Bye.